Okay, so we're going to solve compound inequalities, but we just want to recall that compound inequalities is two or more inequalities graphed together on the same number line. So right now we're going to deal with type number 1, which is the OR inequality. So that just means that we have this inequality or this one that satisfy whatever situation we're in. So we're saying that x is less than or equal to -4, and we know that it's equal to because we have the closed circle and it's heading in the less than direction, or we can have x is greater than 1. So 1 is not included, which is why we have the open circle, but all the numbers greater than 1 are included. So this is how it's written algebraically. And then in interval notation, we write it this way. Remember, the infinity symbols and negative infinity symbols always use the curved bracket. So where the lowest value of this first inequality is negative infinity, so we put it on the left-hand side, comma, the highest value, which is -4, and -4 is included, so we use the square bracket. This U is to say union, so it's joining the two inequalities together. So this one or this one. And so we then specify this as being 1 with a curved bracket or the parenthesis because it is not included. It does not have an equal to sign. 1 is not part of the solution set, but it's a boundary. So we want to indicate the 1, but say that it's not part of the solution set. And the greatest value is positive infinity. So we put that symbol, and again, we use the parenthesis in order to specify infinity, because infinity always carries the curved bracket. All right, so now that we have that, we're just going to solve the inequalities. Well, whenever we solve the OR inequality, it's pretty easy. We're just going to solve the two different parts of the inequality and then show the results on the number line. So this is pretty straightforward, so I'm just going to do number 1 just to show you how it's done. And then I'll give you the answer to number 2, and you'll be able to do the rest on your own. Okay, so we're going to do number 1, and the first thing we have to do is, well, we're going to solve the left-hand side first. So we have two parts, this or this. So we're going to do the left-hand side and solve that. So we're going to subtract 4 from both sides because we notice that our x term is over here, so we want to isolate that x term. So we're going to do that first by getting rid of this extra plus 4 term. We do that by subtracting, so we have 3x is less than or equal to 6. So now we still have to get the x alone, so we're going to divide by 3 because it's currently multiplied by 3. So we have x is less than or equal to 2. So we're going to hold on to that before we graph it, and we'll do the other side. All right, so now on that side we have 5x is greater than 45. So we're going to divide by 5 because that's the only thing that's happening to x. X is currently being multiplied by 5. So when we divide by 5, we have x is greater than 9. Okay, so now we're going to graph these two, and since we have an OR, we can assume that they're not going to point in the same direction. That's not always going to be the case, and you'll see that in probably another example. But let's go ahead and graph this first part. So x is less than or equal to 2, so we're going to put a closed circle at 2, and we are going to point the arrow in the less than direction. Okay, so it's less than or equal to 2, or it can be greater than 9. So we have to specify that. So here's 9. We do not have a closed circle at this point. We have an open circle because the 9 is not part of the solution set. And so we also have to put the arrow pointing in the positive, greater than direction, I should say. So it's heading to positive infinity. Okay, so now that's all that's left is to write the interval notation. So we have to look for the lowest value, and we'll start with our left-hand side. So the left-hand side, the lowest value is this negative infinity. So again, we have the parentheses that specify, that always go with an infinity symbol. So negative infinity, comma, and then our 2, recall, it's part of the solution set. It's filled in. It has the equal to sign. So we're going to use the square bracket to represent that. And then the union of that to this other piece, and the other piece has the lower value of 9, but it's not included, so we're going to put the curved bracket with it, comma, positive infinity, and again, the parenthesis or curved bracket with it. Okay, so now we have number 2 solved, and you can just check your work and make sure that you've got that taken care of appropriately. I'm going to do 3 and 4 and just show you the work, but you should try them on your own and check with the video to see if you got them right. Here's the solution to number 3. Here's the solution to number 4. Notice that I always write everything left to right, least to greatest, and you should do that as well because that's standard notation. So even though up here, when we solve this, it ends up A is greater than -1, because that one ends up being over here, and A is less than -6 is over here. When they solve out, this is fine, but when you write it in interval notation, you really want to put it in the order of where it is on the number line. Here's the answer to number 5. And here's the work for number 6. Now this one, you'll notice, has a few peculiarities. When we have to get rid of this -3/2, I multiplied by its reciprocal, because when we multiply by its reciprocal, notice that the -2 cancels there with the -2, and the 3 cancels there with the 3. So all of the number part goes away, leaving just the x. So you have to do the same on this side and multiply the right side by -2/3. And here I changed the 6 to be 2 times 3 so that the 3's would cancel out, or divide out. And then I'm left with -2 times -2 gives me +4.